Okay, so I'm going to choose time equals 0 to be when it's released. Time final to be when it hits the ground. The origin I'm going to put on the ground beneath the release. And the coordinate system is going to have the y-axis up, x-axis horizontal in the direction of motion. The initial position is 0, 1. The final position in the y direction is 0. The initial velocity is 20, 0. The final velocity we don't know. The acceleration vector is 0, negative 9.81. And we're trying to find time final. And the equation that works here is PFY is equal to PIY plus VIY TF plus 1/2 AY TF squared. So we get 0 is equal to 1 plus 0 minus 4.905 TF squared. And so TF squared is 1 divided by 4.905. And so TF is plus or minus 0.452 seconds. Time, we always want to take the positive one, so positive 0.452 seconds. And so, like you noticed, is there like a live band playing? I like it. So notice that the PIX, the VIX of 20 meters per second never came into the calculation. And that's related to that dropped versus shot bullet video that we watched. Want to know something funny about that video? When so when we watched that bullet video, it recorded on my video, and so then when I loaded my video onto D2L like I always do, and then I put it up on YouTube, and YouTube actually recognized that there was content in my video that was on another YouTube video. Isn't that kind of amazing? Like a video that my screen captured, like YouTube saw that content and like asked if I wanted to like cite the other source or something. Okay, so the fact that it was moving 20 meters per second horizontally never came into the calculation. What if what if it was shot at 20 meters per second, let's say not quite horizontally, maybe something like this? Would that affect the amount of time it took, or would that still, like, what would be the equivalent of that? Would that still take the same amount of time to hit the ground that it would to just drop the bullet? It wouldn't quite, and you know, you can take that, it, you know that if you go all the way to a 90-degree angle and launch the thing up into the air, it'll take longer to hit the ground than if you just drop it, right? So what will this be related to? If you fired this thing at 20 meters per second at an angle of, say, 25 degrees, what's the equivalent one-dimensional motion that'll make it hit the ground at the same time? So actually what you would do is you have this vector that has a magnitude of 20. Say that this angle is 25 degrees. You'd figure out what these components are. Well, actually, let's make it 30 degrees, and then I know what the components are. So this would be 2 times, or 20 times 0.866. That's the cosine of 30 degrees. And this component would be 10 meters per second. And it would take as long for the object to hit the ground as it would to shoot it straight up into the air with an initial speed of 10 meters per second, the y component of that initial velocity. Okay? So that's how that thing works with the x and y components being totally independent. Figure out the component, the y component of that velocity, and the y motion will be exactly the same. All right, I have another problem for you. So let's say that in the standard coordinate system, a helicopter, I always do helicopters because they're easy to draw and fun too, is moving this direction with a speed, let's say that this angle is 20 degrees, and let's say that it's moving at 40 meters per second. And an object is dropped from the helicopter when the helicopter reaches a height of 45 meters. Okay, so before we do this problem, take a second and try to sketch what the path of that object is going to be once it leaves the window of the helicopter. Okay? All projectile motion, all free fall motion is is some part of a parabola. So it's going to be a parabola in some way, whether it's, what part of it is depends on the initial conditions and stuff. But I guess my question is this object going to, when it's dropped out of the helicopter, is it going to fall straight down? Is it going to fall out and down? Or is it going to fall is sort of the wrong word, but is it going to go up and then start to fall down? Which of those three do you think is going to happen here? It is C, yep. So the y component of this 40 meters per second, the velocity of the helicopter, that is going to be the initial velocity vector of the object when it's dropped, right? So, and that has a vertical component of whatever that is. And so the object is not at its highest point yet. Anytime an object is given an upward velocity, it's going to go up a little bit before it turns back around and comes down. So that's what's going to happen here. Okay. So now take a minute, solve this problem. Oh, does it have a problem? No. Take a minute and figure out what the question is. That'd be funny. I'm going to do that on the test. What would I probably ask about this question? What's the displacement of the object, the displacement vector during its fall? No apostrophe on that kind of it. I only did that to prove the point. Okay, so take a minute, work on that together, and then I'll do it.